Welcome to this lesson on linear time-invariant systems, commonly known as LTI systems. In this video, we'll analyze whether two given systems are LTI by examining their mathematical properties. Before we analyze specific systems, let's understand what makes a system linear and time-invariant. A system is linear if it satisfies two key properties: superposition and homogeneity. Superposition means that if input x produces output y, and input x2 produces output y2, then the input x plus x2 must produce the output y plus y2. Homogeneity means that if input x produces output y, then input a times x must produce output a times y, where is any scalar. A system is time invariant if a time shift in the input causes the same time shift in the output. In other words, if input x of t produces output y of t, then input x of t minus t must produce output y of t minus t, where t is any time delay. Now let's analyze our first system, y of n equals -2 times x of -n plus 1. To determine if this system is LTI, we need to check both linearity and time invariance. First, let's check linearity. For a system to be linear, it must satisfy both superposition and homogeneity, which means it can't have any constant terms or operations that aren't scaling or addition. Looking at our equation, we see that it has a constant term plus 1. This immediately violates the homogeneity property because scaling the input won't scale this constant term. For example, if we scale the input by a factor of 2, the output would be y of n equals -2 times x of -n plus 1, which equals -4 times x of -n plus 1. But scaling the output would give us 2 times y of n equals 2 times -2 times x of -n plus 1, which equals -4 times x of -n plus 2. These results are different, so homogeneity is violated. Now, let's check time invariance for the first system. Time invariance means that if we shift the input in time, the output should shift by the same amount. Let's say we shift the input by k, so x of n becomes x of n minus k. The output for this shifted input would be y of n equals -2 times x of -n minus k plus 1. But if we first calculate the output y of n and then shift it by k, we get y of n minus k equals -2 times x of -n plus k plus 1. These two expressions are not equivalent, which means the system is not time invariant. Since the system fails both linearity and time invariance tests, we conclude that the first system is not LTI. Now, let's analyze the second system, y of t equals 2 times x of t minus 1. Again, we'll check both linearity and time invariance. For linearity, we need to check if the system has any operations that aren't scaling or addition. This system only has a scaling factor of 2 and a time shift of -1. There are no constant terms or nonlinear operations. If we have two inputs x of t and x2 of t with outputs y of t and y2 of t respectively, then the input x of t plus x2 of t would produce y of t equals 2 times x of t minus 1 plus x2 of t minus 1, which equals 2 times x of t minus 1 plus 2 times x2 of t minus 1, which equals y of t plus y2 of t. So superposition is satisfied. Similarly, if we scale the input by a factor, a, we get y of t equals 2 times a times x of t minus 1, which equals a times 2 times x of t minus 1, which equals a times y of t. So homogeneity is also satisfied, meaning the system is linear. Now, let's check time invariance for the second system. If we shift the input by k, so x of t becomes x of t minus k, the output would be y of t equals 2 times x of t minus 1 minus k, which equals 2 times x of t minus k minus 1. If we first calculate the output y of t and then shift it by k, we get y of t minus k equals 2 times x of t minus k minus 1. These two expressions are identical, which means the system is time invariant. Since the second system satisfies both linearity and time invariance, we conclude that it is an LTI system. Let's summarize our findings. For system 1, y of n equals -2 times x of -n plus 1. It's not linear due to the constant term plus 1. It's not time-invariant due to the time reversal operation x of negative n. Therefore, system 1 is not LTI for system 2, y of t equals 2 times x of t minus 1. It's linear as it only involves scaling and time shifting. It's time-invariant as a time shift in the input produces the same time shift in the output. Therefore, system 2 is LTI. When analyzing LTI systems, always check for 1. Constant terms or nonlinear operations that violate linearity. 2. Operations that don't preserve time shifts, like time reversal. Understanding these properties is crucial for signal processing and system analysis. Thank you for watching this explanation of linear time-invariant systems. I hope you now have a clear understanding of how to determine whether a system is LTI by checking both linearity and time invariance properties.